Okay, Chapter 2. In Chapter 1, we learned some statistical terms and got to know the data. And in this chapter, we start to learn how to organize the data. We usually organize the qualitative data into frequency table and organize the quantitative data using frequency distributions. For example, we went to the car dealership and collected some qualitative data such as vehicle type and some quantitative data such as the selling prices. And then we can put the vehicle types into mutually exclusive classes on the left and showing the number of observations for each class on the right. We call that class frequencies to get a frequency table. The same thing, we can group the quantitative data into the mutually exclusive classes and show the number of observations on the right to develop a frequency distribution. Here, what does mutually exclusive mean? Which means any particular vehicle cannot belong to the both classes. It's either domestic or foreign, can never be both domestic and foreign. The functions of the frequency table and frequency distributions are showing the general pattern of the data and where values tend to concentrate, and to expose the extreme or unusual data values. For example, from the frequency table we can tell this particular dealership From the frequency table, we can tell that most vehicles that this particular dealership carry are domestic cars, and most of his cars are falling into the price range of 24,000 up to 33,000. And there are only a few cars are expensive cars. After we know the purpose of organizing the data into frequency table and frequency distribution, the next step is how we construct the frequency table and distribution. In this class, we're gonna focus on frequency distribution. First of all, we need to decide the number of the classes. Let's assume K is the number of the classes and N is the number of the total data. So here is a very useful recipe. That is, let's find a smallest K to make 2 raised to the power of K greater than N. So we need to find out the lowest value of the K that satisfies the rule of 2 raised to the K greater than N. For example, assume N is 50. So if K is 5, then 2 raised to the 5 is 32. It's less than 50. Does not satisfy the rule. So let's find another number. 2 raised to the 6. So 2 to 6 is 64 is greater than 50. And 6 is the lowest value we can find to satisfy this rule. Therefore, 6 classes gonna be the good choice. Next, we need to decide on the class width. Once the K is known, the width of each class can be found using this formula. Okay, the maximum data value minus minimum data value and divided by the k. Usually we round this result up to a more convenient number. For example, if we get the class width is 87 or 92 or something like that, we round it up to 100 to make the frequency distribution more readable. Here is a reminder that there is no one correct answer for the class width. Usually there is more than one acceptable way to do it. Next, we need to set the class boundaries. We also call it class limits. We usually need to state clear class limits so you can put each observation into only one category, which means you must avoid overlapping or unclear class limits. For example, this class, the class boundaries is 3 to less than 6 minutes. So 3 and 6 are the lower limit and upper limits respectively. Once we get the number of classes and the class width and the clear class limits, we can then count the number of the observations and tally the numbers in for the frequency. Here we go, we get the frequency distributions. Again, these frequency distributions helping us find out the concentration of the. This is an example that the time that a calling center spend with the customers. So we can tell that the most cases are the calling center, they spend 3 up to the 6 minutes together with their customers. There are 3 more important concepts that we need to know. One is class midpoint, one is relative frequency, and the last one is cumulative relative frequency. Class midpoint is halfway between the 2 limits of the class, and we found it by summing up the 2 limits, then divided it by 2. So for example, this class, the midpoint of this class is 3 plus 6, and then divided by 2, we get 4.5. And for this class, we use 6 plus 9, and then divided by 2, then we get 7.5. Relative frequency distribution showing the proportion of observations of each class relative to the total number of observations. We compute it by dividing the frequency for each class by the total number of the observations. For example, the relative frequency for the third class is 14 divided by 50, then we get 0.28. Cumulative frequencies is we cumulate the relative frequencies. For example, if we want to get the cumulative relative frequencies for the class 3, and then we need to sum up the relative frequencies for the first class, the second class, and the third classes all together. So we need the relative frequency for the class 1 and the relative frequencies for the class 2 and relative frequencies for the class these ones 3 and relative frequencies for this one, and sum them up. Then we can get the cumulative relative frequencies. So far we organized the data in the frequency distribution and showing them in the table. And we can also display the data in the graph. Here we're gonna introduce the histograms. Histogram is a graph in which the classes are marked on horizontal axis and class frequencies on the vertical axis. The class frequencies are represented by the heights of the bars, and the bars are joined, next to each other. Okay, now let's check how do we do it in Excel. First, let's take a look at all those data. Those are the data collected within 50 days and showing the number of the iPads sold in a store. Here, we list the bins. In Excel, we use the term bins for the classes in the distribution. So we get the data and we got the bins, then we can start. First, select the data tab and click on the data analysis in the upper right corner. Then a menu would pop up, and then select the histogram and click OK. In the input range text box, highlight the desired data. That's all the data we need, right? From cell A1 to the cell E10. And for bin range, say bin range is here, is from G2 to G7. Therefore, we select the G2 to G7 into the bin range, and because we did not include any labels, so please do not click label, then click the new worksheets, then click the chart output, then click OK. Here we go, we got the graph in Excel, and now you can tell that for this store, most of the days, that store sold 2 or 3 iPads. Okay, 2 or 3 iPads. So histogram graphically shows the center of the data, where the data concentrate. It serves the same purpose as the frequency distribution. Histogram is actually the graphical display of the frequency distribution. Okay. So if you have any questions, please let me know by email.